you everybody so much for coming out to join us and to celebrate all of the wonderful work of our students. We have a program that'll go for about a little less than an hour, and I want to start by introducing you to Dr. Joan O'Keefe. She is the Director of Science for Harrison, and she's a huge support of our program. We wouldn't be anywhere near where we are without her. So please welcome Joan.
Before I forget, because it's not in my written speech, whoever brought all the food, it's amazing. I know many of our students and our parents brought it, and we all had 7-course meals tonight, so I'm very happy about that. Thank you so much. Welcome, everyone. Thank you for joining us tonight. There's so much excitement in the air. The conversations are fascinating. The displays are mind-boggling. I have to pay so much attention because the work is so complex that if I don't pay attention, I'm going to lose track. Room is so organized, the event is so organized, colorful, and the food is great. And so, great food, great organization, great color, great design makes an event successful in itself. But what do you really see when you take a closer look? Highly independent work from 76 science researchers in sophomore, junior, and senior year. Probably between 14 and 18 years old, just amazing. The culmination of 1 to 3 years of research, idea generation, learning the detailed process for completing a scientific study, applying the process to their own original idea, and learning how best to communicate a study and its results using written language and oral speech. It requires a great deal of determination from our students. It's really just remarkable what our high school science researchers have been able to do. And they don't only do this during their designated class time. Their work becomes a part of who they are, an extension of their growing selves. And I know when you were speaking to them tonight, you could hear that in their voice, the passion. It's important to note that the science research course is not a required course. Students take this because they are curious and fascinated by the living and physical world. They're eager to make their own contribution to the planet and help their fellow human beings. More often than not, there is a personal connection to a disease, a community, and even an ideology. There are so many people to thank for allowing our researchers these opportunities. Dr. Wool and the Board of Education, Dr. Lisa Mulhall, our Assistant Superintendent for Curriculum and Instruction, Ms. Bukema, Mr. Mastrota, Ms. Griffo, our high school administration, mentors from within the community and from outside organizations, and of course our internal review board who actually okays the projects when they involve human participants, and they consist of faculty and administration who've done their own research. And I know you're going to all agree with me that nothing happens without the dedication and support of a fabulous teacher. This is why I want to bring attention to a teacher who has built this program into something that we're all very proud of. A teacher who raises the bar for every student involved. And for 2 students this year, Lauren Davidson and Alyssa Ramiza, it was participation in the most prestigious of research events, the International Science and Engineering Fair in Dallas, Texas. Thank you, Ms. Blunt, for inspiring each and every one of our science research students and for giving us something to rave about. And by the way, if you thought 76 students was too many to manage, we have 87 next year, so yes. So thanks so much, because that's because of all the hard work that you've put into it. Also on display tonight is the work of our design technology program, including design and drawing for production, intro to engineering, technology for the modern sustainable world, and the IB diploma program design technology courses. In this program, students use the design process and computer-aided software to develop ideas and designs that help to solve human needs and wants. Students then build models, prototypes, and products using 3D printers, metals, composites, and wood. I'm truly amazed. If you haven't had a chance before you leave tonight, stop by. It's behind the wall here. The variation, the innovation, the craftsmanship of our engineers, architects, manufacturers, and designers. This program is also an elective program that students choose to participate in. They take this course because they want to bring ideas to life. They think mechanically and spatially, and they want to use their hands to build meaningful and innovative products. Again, it is our teachers who bring this work to life. Thank you to Ms. Frawley, Mr. Schweitzer, and Mr. D'Alessandro, who's hiding somewhere. I don't know where he is. He probably disappeared on us, but I'll embarrass him when he walks back in. Thanks everyone for coming. It's really I'm so proud of everything that our students have done. Thank you to the parents, and enjoy the rest of the evening.
So this is always a very special night for me because I get to celebrate with all of you. It is no small task to get here at the end of the year, and I know all of you know that very well. So congratulations to everybody who is here and to all the hard work that you put in to get yourself here. This was a year of many, many accomplishments. Ariella Blackman was our first Regeneron Science Talent Search finalist. Woohoo! That was top 40 in the country, so that's pretty cool. Lauren Schnapp was our first place winner at Upstate JSHS poster competition. Lauren Davidson and Alyssa Rameza came in top of the fair at WESF and competed at the Regeneron International Science and Engineering Fair in Dallas, Texas. Danny Topper presented at the Duke UNC Alzheimer Conference just a couple of weeks ago. And to all our students who presented so well at NICEF, the New York State Science and Engineering Fair, the WESF, Westchester Science and Engineering Fair, and just this past week at Somers on Saturday, congratulations to everybody who had their moment in the sun. We're very proud of you. As much as we celebrate our science fair wins, I want to take a moment to recognize some of our less visible accomplishments. Not long ago, I received a note from a Harrison High School science research alum, and I wanted to share the note with you. I'm trying to look around to see if she's here. I didn't see her. I saw her on Saturday. So Melissa wrote to me. She said, "I recently started reminiscing about my high school years, and I thought of you. I remember how you went with me to meet Dr. Tagawa at Weill Cornell in New York City. That was my first time ever hearing about an internship. I had no idea what I was getting myself into. It really didn't register in my head how important that experience was at that moment. I just graduated last December, and now I'm once again working at Weill Cornell as part of a research team. We focus on the social determinants of health for home health aides. We recently submitted an abstract for a research conference to which I am the first author. As for my next steps, I'm still aiming high and will be applying to medical school very soon." So for Melissa, this program was about a lot more than just science fair success. There are many research and personal successes to celebrate, just as we celebrate the science fair successes. For each of you, please take a moment to reflect on your own biggest research wins this year. Some of you presented without tears for the first time. Some of you found scientists willing to help you design studies that are very personal to you. I can think of several. Some of you learned what it meant to be on fly time or put the needs of the experimental flies ahead of your own. And many of you dug deep and conducted sophisticated science research studies, either in the lab or the classroom, and/or design sophisticated proposals that you shared with everybody here tonight. Congratulations to all of you. We're proud of all of you and of all of your successes, whether they're big or small. Now, we'll hear from our special guest speaker, Isabel O'Connell. Isabel is a Harrison Science Research alumnus. Guess I should turn that. Did it through? Okay. Who has taken a position as a clinical research coordinator at Mass Gen Hospital. In addition, she just graduated from Cornell University, and 4 years ago, she was here sitting in your shoes. She's the older sister of Harrison High School Science Research current student, Stella O'Connell. Both Isabel and Stella are role models for their younger research peers. Please welcome Isabel O'Connell.
Thank you, Ms. Blunt, for that great introduction. That's basically the first 2 paragraphs of what I'm going to say again, so you're going to hear it all again. So, hi all. I know at least one person in the audience knows who I am, and that would be my sister, Stella, which makes sense since I graduated quite a while ago, in 2019 to be exact. And now, as of last week, I am also a college graduate, and a month from now, I'll start my new job, my new adult job at Massachusetts General Hospital in Boston, where I'll continue exploring my research interests. At Mass Gen, I'll work at the Food Allergy Center doing clinical pediatric allergy and immunology research for the next 2 years. But how did I get here? I mentioned that I graduated from Harrison, and during my time here, I stumbled upon the science research program. I always enjoyed biology, so I thought, hey, why not? I might as well take it. That hey, why not attitude led me to where I am today, and it started me on one of the toughest, most rewarding academic and personal journeys that I have ever been on. I remember some of my strongest emotional experiences from high school sprouting from this class. The frustration of not understanding what I was reading and all of these scientific terms, and then poring over all of these journal articles to try to understand all those scientific terms, and the brain power it took to come up with methodology for my research. And finally, the sheer joy that I felt when I finally placed at WSF, all these emotions I experienced through this program. It was the first time I had to think and learn for myself, and it was so scary, but it was also really exciting. Because of science research, I was able to join a lab, dermatology lab at Weill Cornell my junior year of high school, which meant I got to take the Metro North to Manhattan every week, which was exciting as well. And at that lab, I worked on a project called tumor necrosis factor alpha and adenosine triphosphate cooperating and inducing interleukin-6 release from mast cells, relevance to inflammatory skin disorders, which was a lot for me as a 16-year-old, but it was also very exciting. That experience at Weill Cornell, along with all my other experiences through the science research program at this high school, led me to apply to my now alma mater, Cornell University. At Cornell, I pursued my love for science further, majoring in global and public health sciences and minoring in biomedical sciences. Like for so many others, COVID marked the beginning of my college experience, so it was a challenge to conduct research and join a lab at that time. I didn't let this stop me though, and I made sure to take classes that would support my scientific journey, classes that would give me applicable knowledge for when I was finally able to take part in research again. My introduction to immunology class, which I took my sophomore year of college, was actually inspired by my immunology-based work that I did in high school. This class and the previous immunology work that it built upon motivated me to continue going down the path of medicine and research that I was a little bit discouraged by at the time. In that immunology class, I learned that there is a growing field in research that works to understand how your immune system can play a role in the growth of cancer and also in the fight against cancer. This application of immunology captivated me from the start. And from that moment, I knew I wanted to learn about this area of immunology further in a laboratory setting. Luckily, in 2021, Weill Cornell welcomed me again with open arms, and I got to do research in the Dr. Sandra Maria Lab of Radiation Oncology. In this lab, I was able to tie all my interests together, and I worked on a project that would garner understanding of inflammation in the tumor microenvironment and how hypoxia, which is a lack of oxygen, and radiation can act as factors to either mitigate or promote inflammation. And in the case of cancer and a tumor, inflammation is good news. What I learned in this lab inspired me, and I want to find a similar experience at my home base in Ithaca. That being said, I joined Dr. Anushka Dongre's lab of biomedical sciences at the Cornell Vet School, which again looked at the tumor microenvironment and concurrent resistance to anti-tumor immunity. My work in this lab led me to present at many conferences, and I was even able to publish a paper in Nature recently. At one of the Cornell intercampus symposiums that I presented at, I was able to present to my high school dermatology, radiation oncology, and my current mentor all at the same time. I was able to present all my work, go through my whole poster with all of them standing right in front of me, and that was a very full circle moment for me, and it showed me how everything in my science journey has connected. Science research planted the seeds for my scientific passions, and without it, I probably would not be heading to Boston in a few weeks. Thank you to this program, Ms. Blunt, and all of my mentors. I'm forever indebted to this program for allowing me to dip my toes into the wonderful world of science. I'm so excited to see you all continue to follow your passions like I did, whether that be in science or elsewhere. Science research students, be proud of your hard work thus far, because I know it's very hard. You too are planting the seeds for your future. Congratulations, and thank you for letting me share a bit of my story with you today.
Okay, Magda, are you here? Okay, so next up you're going to hear from Magda Mani. Magda is one of our science fair, award-winning science fair students who was elected by some of her peers to present her research to you here tonight. So without further ado.
Hi everyone, my name is Magda Mani, and I conducted a study in order to determine the extent to which Fucus vesiculosus adapts to changing conditions in the Long Island Sound. I've been fishing with my dad ever since I was young, and this grew my love for the marine life and the environment. This, however, led into my curiosity into the deep world of environmental sciences and how our Long Island Sound is impacted by changing human conditions. Eutrophication is a term used to describe the excess amount of nutrients in the water, and this is caused by excess sewage disposal and fertilizer runoff into the bodies of water, such as the Long Island Sound. This, therefore, eutrophication therefore stimulates excess algal growth, and when a lot of algae grows, it has to decompose thereafter, and when it decomposes, the process consumes a lot of oxygen, and this therefore causes hypoxia, the decrease of oxygen in the water. In the western Long Island Sound, where we all live near, an increase of population therefore increases the amount of disposal and sewage into the water, that therefore increases hypoxia. And as you can see in the graph, the hypoxic conditions in Long Island Sound illustrate that. Here where we live, the hypoxic conditions are relatively high. However, if you go further out east, the hypoxic conditions decrease due to decreased populations and further exchange with the open ocean. Little circles there. So seaweeds such as Fucus vesiculosus, which is native to the Long Island Sound, excessively grow with a higher nutrient concentration. However, prolonged and unnatural nutrient concentration in the water could alter the behavior of the seaweed and therefore cause them to evolve. Bennis in 2016 tested the adaptability of Fucus vesiculosus by transplanting them further upshore to decrease the submersion time of the seaweed. And it was found that the seaweed had an 18% increase of uptake. Topinka in 1978 tested the adaptability of seaweed in different seasons. And it was found in the winter, seaweed increased their uptake significantly compared to the summer. From this, few known studies have explored the effect of natural species and the effect of human-induced behavior, and the purpose of this study was to complete a transplant study to determine if seaweeds from the west could adapt in the east and vice versa. I hypothesized that the seaweed would have adapted in its original location and will not change in their reciprocal location. So I focused on Fucus vesiculosus. It's the seaweed with the little bubbles that you pop. This is found throughout the Long Island Sound, and it is easily obtainable during low tide, and So I decided to change the location of the planting site, so the west versus the east, and measure the change of surface area and mass after 1 month of replantation. I chose to keep the rocky intertidal coastline relatively the same, keeping them planted during the October-November timeline, and making sure they're at the same tidal height for the same submersion time. So I chose to conduct a transplant study focused on the western Long Island Sound here in Larchmont, New York, as well as the eastern Long Island Sound, Groton County, that's about a 2.5-hour drive away. And this spans the entire Long Island Sound. So for collection, I chose to use a paint scraper to dislodge the seaweed from the rock, and I stored them in wet paper towel bags for transportation there and back. I measured them using a scale and a flatbed scanner and used a labeling system where the first 24 samples were the seaweed coming from the west and the last 24 samples were the seaweeds coming from the east. Every odd-numbered seaweed would be planted in the east site and every even-numbered seaweed would be planted in the western site. In order to adhere them to the rock, I used something called marine epoxy. It's a 2-part epoxy used to mix with seawater. And I used the metal tags that were assigned to the samples to adhere them to the rock along with the cable ties they were attached to. So after 1 month, only 10 out of the 48 samples were found, and this impacted my results significantly because the ANOVA test of significance was not significant. However, there is a trend seen where the eastern samples performed better than the western samples in the western site. In order to further statistically analyze these results, I chose to conduct a power analysis in RStudio, where I ran a line of code with the F and P values extracted from summary tables to determine how many samples would be needed in order for this to be significant. It was found that N equals 5, so only 5 samples or 20 samples in total would be needed for these results to be significant. And a lower N value signifies that this is attainable, so if I were to do this again, it would be significant. So a hypothesis was somewhat supported by the data. East performed better in the west, however, not vice versa. And this was seen through the trends in the graph, where the east performed better in the west in the western area. And this was, however, not significant due to a limited number of seaweeds, but with a power analysis test, it was seen that it would be significant with simply more samples. These trends agreed with Peterson in 1994, so a mechanism that seaweed uses is a potential surge component. So when there's a lot of nutrients around them, they take advantage of this and they have a surge in their uptake. And it also agrees with these studies as well, where seaweeds exposed to a deficit area minimize their energy expenditure to not waste enough energy to intake a lot of nutrients. A limitation in my study was snail grazing, and this was very prevalent in the seaweeds in the east, specifically the western samples replanted in the east. As you can see, the bite marks from before and after are visible, and this decreased the surface area and mass of the seaweeds. This is due to because the seaweed coming from a richer nutrient environment. So the composition of the seaweed is richer in nutrients, so the snails found them tastier and ate them all. So that sucked. So we all know humans negatively impact the environment. We're terrible. We're not nice to our native species here in the Long Island Sound. And we see this as Fucus vesiculosus adapts to the changing conditions that we're implementing on the environment. And this could potentially disrupt food web behaviors as we've seen from the grazing snail behavior. So this could eventually lead to unpredictable consequences if we do not act now. So a future study may be focused on seaweed and snail grazing preferences to determine and quantify how these changing conditions affect food chain and consumer preference for the snails. Thank you.
Okay, great job, Magda. Woohoo! Hey. That actually took a lot of guts. Usually you present in front of maybe 20 people, so this is a big crowd. So give her another hand because that was really good. So the last part of our program is always my favorite part of the program, because now it's time for seniors who have been in the program for 3 years. Unfortunately, some of our seniors are sick, but we have amazing seniors who are here, and they are going to have the opportunity that we're going to give them all the mic for 2 minutes, and they can share about their experiences in the program and what the program meant to them.
Hi everybody, my name is Ariella. It's my 3rd year in science research, and I mean it in the truest sense that when I say that this program has truly changed my life. Going into it, I really didn't know what to expect. I was, a little nervous. Like, oh, I have to come up with a study that no one else has done before. How am I supposed to do that? But ultimately, going through it, it has led to incredible opportunities that I never would have gone elsewhere. I've made incredible friends both within this program in Harrison and around the country and around the world presenting at science fairs, and it's been just really amazing to meet so many other people who are passionate about science and have their own diverse interests but still similar passions and drive and just willing to do the incredible amount of work it takes to make these posters and have these presentations that you saw today. So doing that, and also beyond other students, I've met so many incredible people, because if you know anything about my project or I've talked to you, I have sent so many emails over the past few years, just dozens and dozens to people, scientists and engineers and professors, and when I first started, I was like, there's no way any of these people are going to be writing me back, and I'm just a high school student, and what do they want with me? But it has been incredible to hear back from them and get their advice and get their feedback, and it has really influenced me, because now going forward, I am doing my project about a subject that I am truly, truly passionate about, and it's something in general I've always been passionate about, but this has really helped me to grow my interest and really learn about the details of what really makes it work. And if anyone is thinking of joining science research, that's honestly what I would recommend to anyone. Is just the most important thing is to do something that you genuinely care about, because it makes all of the sleepless nights a lot more bearable and a lot more fun. And so going forward, having heard from all of these incredible people and meeting all these incredible people has really inspired me to, as I go forward and I pursue science in the future, something really, really important to me is going forward and then giving back, and maybe being a mentor to another student in the future, or helping people or giving advice, because so many people have been integral to my science research journey, and I can only hope to pass it forward. Thank you. I grew Mars plants. Trying to grow plants in simulated Martian regolith, or Martian dirt, essentially, in order to try and reduce launch costs to make a human mission to Mars more feasible for oxygen production.
Hi everyone. My name is Lauren, and my research was on the effect of copper supplementation on Alzheimer's disease in fruit flies. So I was looking into how supplementing copper in flies with Alzheimer's diets could impact their lifespan and their neurological function, and I did find out that it was ultimately improving their lifespan and locomotor ability, so could be a possible treatment for humans in the future. But one of the things that I really loved about science research, and I think a lot of it Ariella said, was the great community that I found. Although it seems to be a large community, it's really a small, close-knit community. I've made so many great friends, and I continue to see them at science fairs I participate in, and for example, last weekend at Somers, I was able to reconnect with so many of them as judging sophomore projects and first-year projects, and that's been really a great thing to see how everyone's so interconnected and everyone genuinely cares about everyone else's success. But more personally, one of the things that I've really enjoyed about the research program is how much I've learned about myself and everyone else as students. I've met so many really hardworking, passionate students, and I've learned so much about myself in how I can really focus on things that I enjoy, and I've really learned that about myself and how this is something that I really would like to pursue in the future. And I wouldn't have been able to do that without science research, so I really owe a debt of gratitude to that for teaching me that science research is something that I would like to pursue in the future. I've learned a lot about my resilience and my patience and working on fly time. Yeah. I've learned a lot about persistence, even when your experiments don't succeed the first time, and trying to work again and again to get usable results. And so many of those things I've learned to use in classes outside of science research. So for all of that, I really owe science research and my time for the last 3 years a huge debt of gratitude. And I really hope that all of the incoming first years and current students in science research take away all of that and more from their time.
Hi, I'm Nikki, and I also used fruit flies for my experiment. Basically, what I did was I tried to find a way to help manage motor delays in autism besides occupational therapies, and I wanted to find a pharmaceutical approach. And I did that through sodium nitrate and sodium nitrite, and I found that that could increase the performance in fruit flies. So if you want to increase your exercise performance, maybe try some beets or green leafy vegetables and see if it works out for you. I was interested in science research because I remember when I was a freshman, they came in and there was this girl who told us about how she went to Africa. And I was like, oh my gosh, like that is literally the coolest thing ever, sign me up, like I want to do science research. And I came in not really knowing what I wanted to do because it was COVID, and I kind of started out with a COVID project, and then I was like, wait, like I have this huge personal connection and I want to study myself. And that's what I did, and it was really hard. I'm going to be honest, like this is a very hard class, but it is so worth it. The opportunities that I have because of this class are unreal. My presentation skills, on Thursday actually, I get to present to the Academy of Medicine, and I don't think I would have been able to do that without competing in WSF and winning that award that planted me there. And most importantly, Miss Blunt, I would not have been able to do this without her. She is single-handedly one of the best teachers I've ever had in my life, and she pushed me. Sometimes I felt like I didn't need to be pushed, but I really did, and she showed me that she has faith in all of us and that we can all do what we want to do and that we can even go further than we think that we can go. And that's what this class really showed me. And tonight, actually, I got told that my poster is not just a project, and you could see that is a passion. And that is really true, and I am fueled off of that, and that is going to lead me in college to continue this work and hopefully become a doctor. Thank you.
Hi, my name is Ava Cephaloni, and my project was studying the effect of beats per minute of a metronome on heart rate and how that correlates to stress levels in female student athletes. This study was important to me, and I was inspired to do this study because I've been an athlete my whole life. I'm sure a lot of people in the room are athletes, and I will continue to be an athlete, and I think it's really important to find ways to cope with stress levels to prevent the development of mental health issues. Not only in female student athletes, but in male student athletes as well. So, yeah. Oh, science research has taught me a lot. One of the most important things it's taught me is that when you're studying something that you're passionate about, you can succeed a lot more, even though the past 3 years have been very difficult, and I jumped from one idea to the next. Trying to find out and discovering what I'm passionate about will lead me into my future career, hopefully, and what I'm studying in the future, as I'm going to college to study biology and down a pre-med track and hopefully do some more research. So yeah, like science research has been very important to me and has taught me many things, and especially with my presentation skills. You might not see it right now, but it's a lot better when I'm actually presenting stuff that I've been learning. But yeah, I'm really grateful for the experiences that I've had and being able to get out of my comfort zone and present at all these science fairs and just kind of gain passion about my research and what I'm doing, because Miss Blunt has taught me that it's really important for me, and that kind of just like fuels my future and all that stuff. But yeah, so thank you to everyone that's helped me, and especially Miss Blunt.
Hi, I'm Ella. If you asked me 3 years ago if I would be standing up here right now talking in front of all of you, I think I would not believe you at all, and I'd probably be very scared. But science research has brought me a lot of great opportunities that I didn't know at first. Like when I first started the class, I had no idea what I wanted to do. I saw a list of options, and I kind of just figured it out on my own that I was interested in a psychology-based study. And now I'm doing, well, I did actually, a study based on virtual reality and how it affected behavior, and specifically on high school students, hygiene habits, and how well we wash our hands and how well we pay attention to our hygiene habits. And over the 3 years that I've used to figure out my study, I have learned a lot, and not just like learning the topic itself. I learned how to present. I was not good at presenting, but now I think I'm better, way better than I was 3 years ago, and I'm glad the class gave me an opportunity to be like that. Miss Blunt helped me a lot, pushed me a lot also to kind of get to where I am now. And I'm glad she did, because I am proud of my work, and I hope everyone here is too, because I think everyone in the science research classes work really hard for what we created, and we should all be proud to take the class, because I know I am.
Hello, my name is Haku Ijima. I joined this class my junior year, and originally I was taking a freshman course DDP, but I dropped it and joined this class. Originally I joined the class thinking that it could be like a point filler, but ended up being one of the classes that I used most of my time on, and I'm very glad that I took this course. I researched first in junior year about AI technology, and this year I researched about blockchains, which is a way of web security. I think that I've developed a lot in this class, mainly in presenting, since I have really bad stage fright. I think my leg is shaking right now too, but and going to these science fairs and making these projects and learning about things that I actually wanted to do helped me in the long run find my major that I want to go into, which is cybersecurity. And all these experiences helped me move towards this final, goal to stand up here and present. And I feel that without being in this course, I would have been more confused and more stressed about actually going to college, finding a major, finding what I wanted to do. But thanks to this course, I feel like it was a more clear and straightforward path.
Hi, my name is Elena McCann, and I studied the effect of alcohol on the regeneration, lifespan, and the genetic expression of Lumbriculus variegatus, with the main goal of trying to identify the key genes that were affected by the alcohol in relation to FASD patients. I also started my freshman year in DDP, and then I dropped it and transferred into the science research program. I started science research as a sophomore during the pandemic. And due to the pandemic, there were a lot of lab closures, and we had limited class time, so we ran on a hybrid schedule, which means that we had science research 1 to 2 times a week. And I think that because of that, this program, it just demonstrates how much this program cares about every single one of its students, because with the help of Ms. Blunt, every single student standing in this line was able to conduct original research in school or at home because of lab closures. And I just think, I don't know, I'm really happy that we were all able to do that, because it's kind of original about our grade and our class. But additional to the research that I've learned through my project, I think I've also gained a lot of life skills through this course. I think this course has prepared me so much for college, because I've gained public speaking skills, professional communication skills, and I've also learned that it's okay to ask for help, because we've all learned that Through this program, a lot of it's done independently, which means we have to go out of our way to ask for help and ask for questions. And although we have the help of Ms. Blunt, I think it's just super important that we all were forced to be able to ask for help, and this program really pushed us for that. I'm really thankful that I took this course. I think without this course, I also would not be able to stand up here and be able to speak to all these people today, just because I'm also a super nervous presenter. But I'm just really thankful for Ms. Blunt and this course. I've learned so much through my research, and this course has also helped me decide the path that I want to go into in college. I hope to pursue undergraduate research in college as well, and I'm just really excited and thankful that this course has helped me so much through the past 3 years. Thank you.
Hi everyone, I'm Lauren Schnapp, and my research was on strengthening the idea of Drosophila melanogaster, which is fruit flies, as a model organism for narcolepsy. So narcolepsy is a sleeping disorder, and I've always been interested in sleep research. And my sophomore year, I was deciding between a couple different sleeping disorders that I wanted to research. And I originally started with a different project, and then I was redirected to what I ended up studying. And I'm super grateful that even though I had a bit of a pushback in the beginning of my study in 10th grade when I was starting with a different project, I ended up getting to work with Drosophila, which is something I never thought I would be able to do. It definitely built character. Having to work what Lauren was saying on fly time. They're literally your children, and I was there all summer with my flies and everything, but I wouldn't trade that experience for anything else. And I think that's so unique because talking to my peers from other schools are what you were able to do that in your school and just work with fruit flies, and you would never think that these little organisms that annoy us would have such a complex background to them. I definitely think that science research allowed me to really pursue my different interests because I always thought that I wanted to go down more of a business path, and I am very interested in that. But I realized that I do really like science, and that that's something that I wanted to pursue. Also, going back to what Lauren said, the connections you make at these science fairs. I'll be going to Starbucks or something, and I'll see someone I saw at a science fair, and my friend's how do you know them? And I'm I met them at a science fair. So a lot of fun connections and full circle moments. You just meet these great people who have a bunch of very interesting interests, and they turn into these wonderful projects. And I'm definitely thankful. Oh my God, wait, I don't know what just happened there, but whatever. I'm definitely thankful for everything, and I'm glad that I got to experience this and work with fruit flies, and I definitely recommend doing that. So thank you.
Hi everyone, my name is Rachel Kindler, and I studied plant-based milks using a life cycle assessment. So I looked at their economic, social, and environmental impacts because I wanted to help consumers be able to balance both what was good for their bodies and what was good for the environment. Science research has definitely given me the opportunity to explore something I thought I was interested in. I came into science research really interested in nutrition and the fact that a lot of people were following these trends with plant-based milks but didn't know a lot about their nutritional profile. And science research has been able to help me ask a question and derive an actual answer, which I think is something really unique about this class. And I would like to thank Ms. Blunt and my mentor, Dr. Silverman, who is here tonight. They have both provided me with so much support in answering every question and helping me through every step of the way. And I think what I'll take away most from science research is the fact that it has informed what I want to major in, which is public health. Thank you.
They're fantastic, aren't they? Okay, so that basically concludes our program, but before you go anywhere, what we would like to do is we would like to have all the research kids, we're gonna move the chairs back and we are gonna try and fit 76 people into one photograph.